Hi folks, so the questions we have in front of us here today, guys, are from the World of Graphics textbook on pages 254 and 255 on the topic of developments. Okay, so both questions are going to be done in this video here today, and we're starting off with this one here, the magazine holder. So it says here in question 1, the magazine holder, a wall-mounted brochure holder shown below. Draw an elevation in the direction of arrow A, so looking in this direction we'll see this space here, we'll see obviously a bit of this. Okay, some parts of it will be hidden by this space here at the front, and then we wouldn't see these side faces, but we would see them as edge views. Okay, part B, an elevation projected from the, so that should actually, I'd say that's a typo, it should say an end elevation projected from the elevation in the direction of arrow B, so looking at the side face here. And then we have to do a complete surface development of the brochure, and then it says show the location of 2 holes radius 10 in the elevation and development that will allow the brochure holder to be attached to the wall. Okay, so in the kind of graphic here we can see where the 2 holes are there. So I'd imagine the easiest place to put them would be along this kind of a diameter line here. Okay, and we can pick a distance out from the middle, a certain distance out. It has a radius of 30, so maybe out 20 and then 20 that way. Okay, so we'll start with that one there, and then in the second half of the video we'll get onto this bus shelter here. Okay. So, just starting off with that there, guys, what I'm going to do is my arrow A is pointing to the left, so I'm going to keep my elevation on the left of the page. So, just orientate that there the right way. There we go. Okay, so based on how I'm going to develop this out, I'm just working out the overall heights. It's 112. So something, I'm just thinking about coming down from the top. About there, I'd say. We'll do as an XY line. Keep it on the left of your page. Probably a little bit long for an XY line, but it'll do. So X, and I'll put in the Y in a second. So the front of it is 60 millimeters long. I'll mark 60 there. And I'll keep a gap between my view of 15, and I know the width of it from my end elevation, which is pointing in the right, so it's going to go over here on this side. The width of it is 25, so marking 25 as well. And now, just so I know, then I'll put my Y there. Okay, so there's my XY line, and now starting with the elevation, I'm going to draw this up. It's 112 high, 56 and 56, there we go. And then obviously I have a curve at the top, I should say a semicircle, and the radius is 30, so having 60 long, I'm going to mark in 30 millimeters and project a line up. So it's 30 there, and then measure down 30 millimeters, so from 120 down to 90 is 30 there. So nice and easy. Just make sure you can see that there. Perfect. And having found the center, I can now draw in my semicircle. I'll get that drawn in there. Just set up the compass here. So, drawing the semicircle at the top. Heavy it in after. There we have the semicircle. And now just heavy in the rest of the detail. Okay, so I know it is heavy all the way up as far as the semicircle. So I can heavy in this, I can heavy in this portion here, and then it also tells me that coming in it's 14 and 14 and a height of 38. So along the front I have to measure 38 millimeters up. Make sure I get exactly 38 there. Happy with that. Project a line across, I'm going to need that line over here as well. I'm going to need this one too. So might as well start on my end elevation. So there's the end elevation there, nice and quick. I'll heavy that in a minute. And then along this line here, okay, at the height of 38, it's in 14 and in 14, so 60 there, and then 14 in there, and I'll mark 14 back as well. And then it says the angle in here at those two 14s, make sure that's 14, my lord, I measured 19, so there we have it. Okay, at those two 14s, it'll project down at 45 degrees, okay, nice and easy. And that there is kind of the front cover there for the brochure holder. So it said in here we had an angle of 90 degrees, and if by using a little bit of smarts and a little bit of maths, that 90 degree angle in there, okay, is made by two 45 degree angles going down here. Okay, so those angles right there are 45 degrees. Okay, very important. And then obviously the last little part of this on the elevation view is just heavying in my arc. So just heavy in the arc there. There we have it. Okay, a little bit of inaccuracy there, apologies for that. And now the next bit I have to heavy in is my end elevation. So I know I have an edge running all the way to the top, and I also have that line there, and then this inclined line here, or sloped line. Okay, and that face there, okay, is technically this edge here. Okay, now the next little bit is, it tells us in the question to show the location of two holes radius 10 in the elevation. So for two holes to be radius 10, what I'm actually going to do is I'm going to measure out 20 millimeters, just to have it, 20 and 20. I'm going to put them up here and here. And for two holes to be radius 10, now this is quite hard to draw, or to scribe I should say, an arc. So radius 10, maybe not 20 actually, I just realized, because that would be too close. So I'm actually going to measure out 15 either side of the middle. So I'm going to measure 15 and 15. And then after the 15 I'm going to mark my 10. So there's 10 there and 10 there. I'll come back and I'll heavy these in a minute. So just using the pen, it can be a little bit awkward, so I'm trying to do this as best I can. So it says two holes radius 10. Yeah, that's right, just making sure. Being quite big, to be honest. Maybe two holes, based on scale wise, I think two holes radius 5 would be a little bit better, but they'll do. We'll just do what the question says anyway. So there's our two holes. I'll heavy those in a minute. Now what we actually have to do is we have to complete the surface development. We've completed the elevation, okay, view A, and we've also completed the end elevation, view B. Now what we have to do is complete the surface development. So as always, work out how many surfaces you have. So we have a back surface, okay, that is going to take this shape. We have two side surfaces that are going to have this shape here, okay, that are going to be connected onto the back. And then we also have a bottom, okay, which is going to be 25 wide and 60 long, okay, and then we have a little bit of a bit here at the front. Okay, so the easiest way to do this is projecting out. We already have our heights, so project out your line here, okay, to the right. I'll just pull it over there like that so you can see it a little bit better. And I'm going to transfer over my overall height, which is up there like that. I'm actually going to start then by putting in a line here. Start it out about here, and from there, from that line there, I'm going to measure out 60 this way, because that's the 60 distance there. Nice and easy. And then I also have to measure out where it's connected on here, this distance here, which is 25, and that will go either side. So 25 of the 60 this way and 25 this way. So that'll be the start of it. Project this line all the way up. Construction line to start off with. This one needs to come up a certain height. And then, using this point here and this height, okay, I'm going to join these up. So this one all the way across to there, and this one to there. And as you can see then, at this point here, I'm going to connect this guy up to this fella here, and the exact same here. And then the last bit, I am going to connect over this, because that's the height where my center is, and mark in 30 millimeters. It's 60 long. There's my radius. Scribe in my arc for my semicircle. So there's the semicircle arc. So we have the back face, we have the side, we have the side. Now I have to get the bottom and the front. So for the bottom and the front, they're going to connect on here. Okay, I connect the bottom on there, and it's very simple. It's going to be the same distance because it has to match up with the sides. So I could, if I wanted, take that distance there on my compass, swing it around, and that's the same distance down. Okay, nice and easy. So that'll be the bottom face. Now, at this point, I could attach the front on here, or I could attach it on over here. And for the sake of today, I'm going to actually attach it on over here. Okay, so it's going to be the same distance out. Once again, it's going to be 60 millimeters out. And I'm going to project the line up here. Project this line across. And I know then that these distances here are in 14 and 14 either side. So I'm going to mark in 14 and mark back 14, and then I know they project down at 45 degrees. This one 45 and 45. So there you have it. That is the side, the back, the bottom, and the front. Now this front could have gone here, but the only, down here. This bit could have gone down here. The only issue is obviously then it would have to have been this bit here, this kind of little V section that's cut out of it, would have actually been the other way. It would have been upside down. Okay, because obviously it would have to fold back up. Okay, so at that point now also I have, the two holes as well, which were out 15 and 15. And I'll mark the 10s while I'm at it. So 15 out, mark the 10. So there we have it, and as best I can, once again, I want to do these as neat as I possibly can. So bear with me there now. So there's that one, and the exact same with this guy here, without slipping. Right folks, so that's actually it done there. I'm just going to heavy into detail, so I'm just going to speed up the video there while I do that. Right folks, that is the development question there on the brochure holder completed. As you can see, we've got the elevation, the end elevation, and then the development of the surface here. As I speed up the video, you can see here I have put in the hatched lines here, which are going to show these are fold lines, okay, where everything is going to actually fold back together. The only bit here where you could have also changed it up a bit here was the front surface, which could have also been attached on down here, okay. Also then as well, we also had to put in 2 radius 10 holes on the brochure so it could mount onto the wall. Now radius 10 is quite big, as you can see, okay, but that worked out fine. I just picked the distance out from the middle, 15 either side, and then I did my radius 10, okay. So hope you found that helpful, guys. We're going to move on to the next question now on this, which is on the bus shelter. Okay. Right folks, so the next question on this page is the bus shelter question, and it says a bus shelter is shown below. Draw an end elevation in the direction of arrow A. So an end elevation in the direction of arrow A, so we're going to see this side face here, and then an elevation projected from the end elevation in the direction of arrow B. So basically all that means is our end elevation is going to go on the left of our elevation is going to go on the right. Okay, so make sure your view B, which is our elevation view, goes on the right of your end elevation. And it also says the complete surface development of the object as well. So just looking here at the object, okay, so if we're starting with this kind of side face here, okay, the reason we have to do that is because it doesn't actually give us the overall height of the whole object. It does tell us this back edge here is 56 high, excuse me, and it also tells us this bottom edge here is 32 long. It does not tell us the exact distance out to this point. It does tell us that the line, okay, which is inclined at an angle of 15 degrees and is 44 millimeters long, and we're going to have to use that to work out the overall height of the object. And then we can see obviously the overall length of it in this direction, in the direction of arrow B, or elevation, is 88. So we're just going to have to, from this point, once we have these two edges drawn, okay, we're going to do an angles line at 15 degrees, and then using our compass, okay, we're going to scribe an arc 44 millimeters long to cut through that line, and that will give us a definitive point there. At that point there I can connect it down, and that will be the view drawn, and then we will start with our elevation view. Okay, so that's where we're going to start, and then we will complete the surface development. So I'll just zoom out there a little bit. So once again, I'm going to keep this on the left hand side of my page, and I'm going to keep it up. I'll just actually keep it low enough this time. I'm just thinking base, there's actually only 4 faces. Yeah, so I'll keep it actually a bit lower this time. So I'm going to construct an XY line, and starting off with my end elevation, I'll actually put that line in heavy straight away. So something like that. I'll put X there, and when I have the other one I'll put in the Y. So starting off, I know that bottom edge we said was 32 millimeters, so marking 32. And I also know that the edge here went up at a height to 56. So line up 56. Construction line, probably took it a little bit farther, as you can see. Just zoom in there so you can see it a little bit better. And bring this over here. There we have it. So construction line up, measure 56, and now what I want to do is from that point right there, I want to go at an angle of 15 degrees. So 15 degrees. So I'm going to use my protractor, and I'm actually using my T-square to help me keep it in line. So put it on, make sure your zero or the center of your protractor is on the point, and I want to measure up 15 degrees. Okay, so you can see between 10 and 20, 15 is there. And at that 15, I'm now going to connect that over. And the distance along that is actually at 44 millimeters. So as I said previously, you could use a compass, but I'll actually just measure along the line 44. I have the line, measure along it now, 44 millimeters. At that point, right there, that is our overall height, and now I can connect that back down here. So there you have it, nice and easy. That is our end elevation completed. Okay, simple line, 15 degrees, and then getting the end point. And as you can see, with it being a bus shelter, there's obviously a little bit of an overhang of where people will obviously be under here, and we can see the overhang. And now we actually have our overall height. So using that, we can now construct our elevation. And our elevation was pointing to the right, so it goes on the right of the end elevation. So it's going to be 88 millimeters long. So I'm going to keep a distance between my views of 15. Then I'm going to mark 88. There's my 88. Project those heights up. I know I need them up to about there. Having found the height in the end elevation, project that across, and that across. And there you have it. Once again, just heavy in the important detail. So this line I do here is actually this face. So that line there is actually this face when we're looking straight at it, only we see the face as an edge view, otherwise known as a line. Same thing with this side. And then I have to heavy in this line here, because it's an open bus shelter. There's only 4 faces, 2 sides. There's 2 side faces, the back and the top. And then that back edge there is actually this back edge here, okay, as we're looking in at it, okay. And then this point here is actually this line up here, okay. So there's the bus shelter, elevation, end elevation completed. Now what we're going to do, and I'll just zoom out there a little bit, I'm going to bring this over here. Now what we're going to do is we're going to complete the surface development of it. And starting off, I think the easiest way to do this is obviously back face, 2 sides connected onto it, and then the top face above it. So take our heights that we already have, and what we're going to be using here is actually true lengths as well, okay. So back face is at this height here, and then starting off, connected on here, I'm going to pick that as my start point. From there I'm going to measure over 88 for the back face, so 88 right there. And then this bottom edge here is at a distance of 32 millimeters, so measure 32 there, and then measure 32 out the opposite side. Good, use your compass. And what I want to do is I want to connect over the height for this one, so bring that across as well. And now there is a couple of ways you could actually do this. I could actually just work out the angle, okay, 15 degrees up from here, and that'll help me. Or what I could do is I could take this distance on my compass, and this is very important, and this is actually what I want to get actually. So I'll just explain this. That line there is a true length, okay, very, very important. That line there is a true length. The reason it is a true length is because when you look straight at a face and you see the true shape of the face, all the lines on the true shape are also true lengths, okay? So as we look straight at the side of the bus shelter, okay, we could see this shape. Therefore, this line is a true length. This height up here from here to here is a true height, so it's also a true length from here, and a true length from here. Having that as a true length, I can now take that true length here, 44, I can take that on my compass, and then I can go to this point and I could scribe an arc to cut through that point there, and then I could do the same at the opposite side there. And having found those, I can now make my life a little bit easier. Rather than using the protractor twice over, connect that to there, that to there, here to here, and then here to here. And at this point now, the last little bit I have to do is I have the side, I have the side, I have the back, now I have to do the top. And we know the top is connected up here. So directly above the back, I'm going to extend this line up here, like that, and like that. And I know that the top is the same distance as this here going up. So once again, with this distance on my compass, I could actually rotate that, and as you can see there, and I could also do it from the other side opposite as well, don't need to, once you're done from one, but just showing you that they should match up. So that distance there has to be the same as this distance here, which is both our true lengths from over here, okay. And at that point there at the top, connect this across, and there you have it. Once again, that is our development done, so I'm just going to quickly heavy that in. Okay, so there you have it, guys. Just on that there again, once again, just putting in little arrows here just to show you, okay, that the faces need to match up. This distance here should be the same as this distance here, and vice versa on the opposite side, and they are true lengths, okay, which we took from over here. Now we knew the distance was 44, but obviously we used the angle then to help us at an angle of 15 degrees, and that gave us the overall height of it as well. Once we had the overall height, we could transfer that across. So that's the surface development question there, guys, on the bus shelter, and the first question also on the brochure. Okay, I hope you found them helpful. There are the questions complete. Okay.